Welcome to the presentation on sulfur ylides. There are two important sulfur ylides, namely dimethyl sulfonium methylide and dimethyl sulfoxonium methylide. Among these two, dimethyl sulfonium ylide is not stabilized by any factors like resonance, whereas dimethyl sulfoxonium methylide, which we call as sulfoxonium ylide, is stabilized by resonance. Therefore, when we compare the reactivity of these two ylides, sulfonium ylide and sulfoxonium ylide, sulfonium ylide is more reactive than the sulfoxonium ylide. The preparation of sulfur ylides involves two steps. The first step is the treatment of dimethyl sulfide or dimethyl sulfoxide with a methyl halide. And this results in the formation of the trimethyl sulfonium salt or trimethyl sulfoxonium salt. In the second step, the dimethyl sulfonium or dimethyl sulfoxonium salt is deprotonated with a strong base to get the corresponding methylide, which we call as the sulfur ylide. When phosphorus ylides are treated with aldehydes or ketones, we end up with the alkenes. That is what we call as Wittig reaction. Whereas the sulfur ylides on treatment with aldehydes or ketones, we get epoxides. Here I have given examples for the reactions of sulfonium ylide and sulfoxonium ylide with aldehydes. The sulfonium ylide with its carbanion part behaves like nucleophile and it is attacking the electrophilic carbonyl carbon of the aldehyde, and this results in the formation of a mesoionic intermediate, and this intermediate undergoes a SNI reaction where the O- is the nucleophile, sulfur with the positive charge is the leaving group. Sulfur with the electronegative element with the positive charge is a very good leaving group here. Therefore, the SNI reaction takes place here, resulting in the formation of an epoxide. A very similar reaction is taking place with the sulfoxonium ylide also. Here again, the carbanion part of the sulfoxonium ylide is attacking the electrophilic carbonyl carbon, resulting in the formation of similar mesoionic species, which is undergoing a SNI reaction, resulting in the formation of epoxide. So in case of Wittig reaction, the phosphorus ylides react with aldehydes and ketones to give you alkene, whereas here the sulfoxonium ylide and the sulfonium ylide react with aldehydes and ketones to form epoxides. Here are a few more examples given to explain the formation of epoxides from ketones. So this is cyclohexanone, which on treatment with the sulfonium ylide gives you an epoxide. Similarly, the sulfoxonium ylides also react with ketones to form epoxides. As I have already said, the dimethyl sulfonium ylide is more reactive than the dimethyl sulfoxonium ylide. It is because the dimethyl sulfonium ylide is stabilized by resonance. I have shown the resonance structures here, and you can find that there is a higher dispersal of negative charge between carbon and oxygen here. Whereas in dimethyl sulfonium ylide, there is no such dispersal of negative charge. Therefore, this dimethyl sulfonium ylide is less stable or more reactive, and so it is a hard base. Whereas the more stabilized dimethyl sulfoxonium ylide is less reactive and it is a soft base. This dimethyl sulfonium ylide and sulfoxonium ylide are reacting in a similar way with aldehydes and ketones, but they react in a different way with alpha beta unsaturated carbonyl compounds. Here is an alpha beta unsaturated carbonyl compound, and I have given its resonance structures here. In one of these two resonance structures, we find positive charge on the carbonyl carbon. As this carbonyl carbon is directly connected to the electronegative oxygen, this carbonyl carbon has higher concentration of positive charge. Since the charge concentration is more here, it is behaving as a hard acid. Whereas in the other resonance structure, the beta carbon is holding positive charge and it is far from the oxygen. As it is far from the oxygen, it has less charge concentration here. As the concentration of positive charge is less on beta carbon, it is behaving as a soft acid. So according to hard and soft acid base principle, the HSAB principle, hard bases react with hard acid, whereas soft bases react with soft acid. As I have already said, the dimethyl sulfonium ylide is a hard base, therefore it reacts with the carbonyl carbon. Whereas dimethyl sulfoxonium ylide is a soft base and it reacts with the beta carbon. When dimethyl sulfonium ylide reacts with the carbonyl carbon, it results in the formation of an epoxide. Whereas the dimethyl sulfoxonium ylide reacts with the beta carbon and it results in the formation of the cyclopropane derivative. And I have given some examples here. Here I have shown the reaction of dimethyl sulfonium ylide and dimethyl sulfoxonium ylide with an alpha beta unsaturated carbonyl compound, the methyl vinyl ketone. In dimethyl sulfonium ylide, the carbanion is a hard base, therefore it is reacting with the hard acid, the carbonyl carbon of the alpha beta unsaturated carbonyl compound, and this reaction results in the formation of an epoxide. Whereas dimethyl sulfoxonium ylide is also having a carbanion which is a soft base that reacts with the soft acid of the alpha beta unsaturated carbonyl compound. The soft acid is the beta carbon. So the carbanion reacts with the beta carbon and that leads to the formation of a cyclopropane derivative. Here is another example to explain the reaction of dimethyl sulfonium ylide and dimethyl sulfoxonium ylide with alpha beta unsaturated carbonyl compounds. Here dimethyl sulfonium ylide having a carbanion, a hard base, reacts directly with the carbonyl carbon leading to the formation of an epoxide. Whereas the stabilized ylide, the dimethyl sulfoxonium ylide with a carbanion which is a soft base is reacting at the beta carbon and that is leading to the formation of a cyclopropane derivative. So from all these reactions you can understand the unstabilized or the more reactive dimethyl sulfonium ylide reacts with alpha beta unsaturated carbonyl compounds to form epoxides, whereas the stabilized sulfur ylide, dimethyl sulfoxonium ylide having a carbanion which is a soft base is reacting with the alpha beta unsaturated carbonyl compound to form cyclopropane derivative and not an epoxide. Just like dimethyl sulfoxonium methylide, here is another stabilized sulfur ylide. This sulfur ylide is nothing but dimethyl sulfonium methylide with an electron withdrawing group connected to the carbon bearing negative charge. This electron withdrawing group is normally a minus R group like carbonyl or cyano group. So when a minus R group is connected to this carbon bearing negative charge, it is involving in resonance. Therefore, this negative charge is not fixed to this carbon, is not localized to this carbon, and it is dispersed between carbon, carbon and nitrogen. Therefore, the concentration of negative charge on this carbon is always less. Therefore, this carbanion behaves as a soft base. Since it is a soft base, when it is treated with an alpha beta unsaturated carbonyl compound, it reacts with the beta carbon, which is a soft acid. So, this stabilized sulfur ylide is reacting with the beta carbon of the alpha beta unsaturated carbonyl compound as shown in this reaction, leading to the formation of a cyclopropane derivative and not an epoxide. Thank you. Have a passion for learning organic chemistry and learn more. Thank you.